Guys, let's do this problem right here. The question is asking an air-filled parallel plate capacitor has round plates and carries a fixed amount of equal but opposite charge on its plates. All the geometric parameters of the capacitor are now doubled. So they are saying plate diameter and the plate separation are doubled. If the original energy stored in the capacitor was U0, the new stored energy is what? So that's the question. So let's see how we can find this one. So in order to do this, we have to know the energy equation, right? So we know that energy is equal to half QV. So here we are dealing with capacitor and capacitance. Here this is nothing related to capacitance, so we have to create a relationship. So we have to replace something. We know that Q is equal to CV. So here what I can do is I can rearrange Q in terms of CV, or V in terms, we have to plug something in terms of C. So here V is going to be equal to Q over C, and if I plug Q over C instead of V, that's going to give us half Q square over C. So that's going to be the new equation. So we have the equation now, half Q square over C. Now we have to find the capacitance for both situations. So let's look at the first situation, initial situation. So we know that to find the capacitance, we use capacitance equals to epsilon naught A divided by D. So here the area is going to change, also the distance is going to change, because they are saying diameter is changing and the plate separation is changing. So these two are going to be doubled. Actually, the diameter of the area is going to be doubled. So let's look at the original condition when we don't change anything. So we know that the area of the, since they are saying it's a round plates, we are going to use the area of the circle. So area of the circle is going to be phi r square. Since it's related to diameter, we know that d by 2 is equal to r radius. So if I square this one, this is going to give us phi d square divided by 4. Right? So here we are going to have, instead of area, we can plug phi d square divided by 4. So this is going to be epsilon naught times phi d square divided by 4 times d. So this is when we don't change anything. So let's say this is initial C naught, right? And when we double the diameter and the plate separation, and let's see now what capacitance we get. So we are going to use the same equation. C naught is equal to epsilon naught A prime, let's put A prime D prime. So here the new distance is doubled, also diameter is doubled. So if we double the diameter, before we had d by 2, now if you double this one, that's going to be just d. So the new area is going to be just phi d square. So we can plug that one right here. So this is going to be epsilon naught times phi d square divided by the new distance is going to be doubled. So this is going to be just 2d, right? So this is the relationship. So let's now bring this one and compare these two. So we have 1 over 2d, and in which value, if I multiply this one, it will give this value. So if you see, this is actually 2 times of this. If you multiply 1 over 4 times 2, you will get 1 over 2. So we can say this one, 1 over 4 times 2. So C prime is equal to 2 times C naught, right? So this is the relationship we have formed between these capacitance. So now let's go ahead and plug in this energy equation. So here we have this energy equation, U is equal to half Q square over 2C. So let's look at the initial condition. Initial condition is just going to be C naught, right? When we don't change anything. So that's going to be C naught. So we are going to have half Q square over C naught. And when we double the capacity, double the distance and diameter, we get 2 times C naught. So that's C prime. So we can plug half Q square divided by 2 C naught. And now let's look at the relationship between these two. I can write this one as 1 over 4 Q square over C naught. And again, this is 1 over 4, this is 1 over 2. So if I multiply by which value, I will get this one. So let's see, 1 over 4 times 2 is equal to 1 over 2, right? So if I, this is actually half time of this one. U prime is equal to u naught divided by 2. If you see, if you divide this one by half, like we have half right here, if you divide this one by 2, you will get 1 over 4. So u, therefore we can conclude u prime is equal to u naught divided by 2. So that's going to be the answer for this one. So the answer for this question is u naught divided by 2, and that's how we find these kind of answers. I hope you guys find this video helpful. See you next time.